What if we could teleport the oceans to Mars? Hey everyone, welcome back to What If Explores today. We're diving deep into one of the most mind-bending what-if scenarios. What if we could teleport Earth's oceans to Mars? Would it turn the red planet into a second Earth? Or would it lead to catastrophic consequences? Let's explore this wild idea, and we're talking about one of the most ambitious projects in human history, SpaceX's mission to Mars. Buckle up, because we're about to dive into the future of space exploration. First, let's break down the numbers. Earth's oceans hold about 1.332 billion cubic kilometers of water. That's a staggering amount, so much that it covers over 70% of our planet's surface. On Mars, however, water is scarce. It's mostly locked away in ice caps at the poles or hidden beneath the surface. So let's imagine we have the technology to teleport all this water to Mars. In an instant, Mars would go from a dry, barren world to one covered in oceans, seas, and lakes. But would this really make Mars more Earth-like? Not so fast. Mars is a very different world from Earth. The gravity on Mars is only about 38% of Earth's, meaning the water wouldn't behave the same way. Instead of flowing into familiar shapes like rivers and lakes, the lower gravity would cause water to spread out more evenly, creating vast, shallow seas rather than deep oceans. Another big challenge: the atmosphere. Mars has a thin atmosphere, composed mostly of carbon dioxide with little to no oxygen. This atmosphere is also much less dense than Earth's, which means it can't hold on to heat as well. Without the protection of a thick atmosphere, most of the water could quickly evaporate or freeze, depending on where it's located on the planet. Temperatures on Mars can plummet to minus 80 degrees Fahrenheit, minus 60 degrees Celsius, at night and in winter, which means that without a way to warm the planet, much of the water would turn into ice or sublimate into the thin atmosphere. But let's say we somehow managed to keep the water in liquid form. Would we then have a habitable planet? Sadly, it's not that simple. Mars lacks a magnetic field to protect it from solar radiation. Earth's magnetic field shields our planet from harmful solar winds. But without it, Mars is constantly bombarded by radiation, which would be deadly for any potential life. This means that any water we teleport to Mars would be exposed to these harsh conditions, potentially breaking down over time and stripping the planet of its water all over again. So, teleporting Earth's oceans to Mars might not turn it into the paradise we're hoping for. In fact, it could lead to a host of new problems, from freezing seas to radiation exposure. But if we could also terraform the planet by thickening its atmosphere, creating a magnetic field, and controlling the climate, then maybe, just maybe, we could make Mars a new home for humanity. Terraforming Mars is still the stuff of science fiction, but who knows? With advances in technology, what seems impossible today might become reality tomorrow. Let's talk some about the SpaceX mission to Mars. What will happen to Earth? And is that even possible in the future? Central to this mission is Starship, a fully reusable spacecraft designed to carry up to 100 passengers to the Red Planet. Starship is unlike any spacecraft we've seen before. It's built to land on Mars, return to Earth, and do it all over again. But getting to Mars is only half the challenge. SpaceX is also working on how to sustain human life once we're there. From generating oxygen and water to growing food in the harsh Martian environment, the company is tackling problems that sound like they're straight out of science fiction. SpaceX plans to send the first humans to Mars in the next decade, with hopes of building the first colony soon after. The vision? A self-sustaining city on Mars, a backup for humanity in case something ever goes wrong here on Earth. Teleporting Earth's oceans to Mars is a fascinating thought experiment. But let's break it down in terms of feasibility and consequences. Is it possible? Current technology. As of now, teleportation, especially on such a massive scale, is purely science fiction. While quantum teleportation exists at the level of subatomic particles, scaling this up to teleport an entire ocean, or even a glass of water, is far beyond our current capabilities. Future prospects. Theoretically, if technology advanced to a point where teleporting large amounts of matter became possible, it would require an unimaginable amount of energy and incredibly advanced understanding of quantum mechanics. We're talking about technology so far ahead of us that it's difficult to predict when or if it could ever be achieved. What would happen to Earth? Environmental catastrophe. Climate impact. Earth's climate system is intricately linked to its oceans. The oceans regulate temperature, drive weather patterns, and are crucial for life. Removing them would disrupt the water cycle, likely causing temperatures to rise dramatically due to the loss of heat distribution and evaporation. Atmospheric changes. Without the oceans, the humidity levels in the atmosphere would plummet, leading to extreme aridity. Deserts would expand, and most plant and animal life dependent on water would face extinction. Biodiversity collapse. Marine life, which makes up a significant portion of Earth's biodiversity, would be instantly wiped out. This would have a cascading effect on all ecosystems, including terrestrial ones, as the food chain collapses. Geological instability. The weight of the oceans also plays a role in stabilizing Earth's tectonic plates. Their sudden removal could lead to increased seismic and volcanic activity. Human impact. Mass extinctions. Humanity, along with most other life forms, would struggle to survive without access to fresh water. Coastal cities would become uninhabitable deserts, and the global economy would collapse as agriculture fails and resources dwindle. Possible survivors. Some humans might survive in technologically advanced, controlled environments, like domed cities or underground bunkers, but the Earth would be a vastly less hospitable place. Could it be done in the future? Terraforming instead? Rather than teleporting oceans, future technologies might focus on terraforming, gradually transforming Mars to support life. This could involve importing water through less extreme means, like melting ice caps or redirecting comets, thickening Mars's atmosphere and warming the planet. These ideas, while still far-fetched, are being seriously discussed by scientists. Ethical and practical considerations. Even if teleportation were possible, the ethical implications of stripping one planet of its oceans to terraform another would be profound. The environmental devastation on Earth would likely outweigh any benefits gained from terraforming Mars. Conclusion. Teleporting Earth's oceans to Mars, while a fun what-if scenario, is not only impossible with current technology, but would also spell disaster for our planet. The future of space exploration and colonization might instead lie in more sustainable and gradual approaches like terraforming that respect both Earth's and Mars ecosystems. While it's unlikely that we'll ever face this exact situation, it serves as a reminder of how interconnected and fragile our planet's systems are, and why preserving Earth should be a top priority.